Hello, in my Google Earth tour, I will talk about the event associated to the formation of the big desert in the world. So here I have a KMZ that shows the global precipitation, where the dark blue represents more rain, and the lighter actually represents low rates of precipitation. So also I have those pins that represent some of the big deserts in the world. So here we have the Kalahari Desert. Here we have the Sahara Desert, and here we have Australia, or I think here, yeah. And then what those deserts have in common? They are located where have low rates of rain. The deserts also are classified, defined by places where have more evaporation than precipitation. So those areas where receive low rates of rain are here also the deserts. So I'll turn off this layer so you can see better. See here, here's the Sahara. You have all the desert here in South America, California, United States. And what else those deserts have in common? They have in common that they are located around the latitudes, the 15 to 30 latitudes. Here we can see this one. Also can see this one also located on this area. Also Australia, it's located around those latitudes. Here 25. So why the deserts are located on those areas? This is associated to the Hadley cells. I'll turn on this layer again. The Hadley cells is one cell that occurs between the equator to the 30th latitude. The equator receives high rates of solar radiation. For this reason, this area it's way warmer than the other areas, and with the hot air here, it's also more humid because hot air can hold more moisture. And then this hot airs get lighter, it's rise and arrive on to the around 10 to 15 kilometers above the earth. And at its rise, um, imagine it's like a T, a letter T, that it goes up because ascending air has a cyclonic movement. So it's rise and it's go to the direction like north and south. And as it rise, it get cold adiabatically, and then this moisture condense. That's why we have a lot of forming the rain. So we have a lot of rain around the equator area. And as this air moves towards the tropics, both north and south tropics, it's um, as it's very high, it gets colder, and also it's dry because all these rains events happened. So as it gets colder, it's moved to and moves to this area. Around this area here, as it's heavy because it's cold, it goes down again, and this air moves back close to this Earth's surface to the equator line. So it forms a kind of a cycle from here, the equator, to the tropics. That's why we And then this air goes down here on this area in the 30s, and it's very dry, and it makes that area very dry too. That's why I have a low rates of rain on those areas. So, other event that happens here I'll turn off this layer and turn another one. This is U.S. rainfall. This is a Washington state. And another event that happened here um, is as the warm moisture come from the ocean, it's finding here a range of mountains. And then you can see here we have degrees. Here it's dark green. It's where it rains more, and the lighter green is where it rains less. So, um, as the hot, the warm moisture air finds the mountain, it's forced to lift, and as it lifts, it get cold, and those moisture condense and forming the orographic rings. And as the air arrives on the top of the mountains, it's forced to the other side, but when it's arrived to the other side, it's dry, making the other side of the mountains very dry too. So I'll turn off this layer here so you can see better. We have this mountain range here. And you can see how this area here, the western, is way more green, greener. It's also when you turn the layer, we can see more rain to happen here. And then the other side, we have a low rates of rain. So that's why we have eastern Washington dry and a lot of rains on western Washington. So thank you.